Hello everyone. In this very video, we are going to continue with the application of first order differential equation. But here we are going to look at its application in electrical circuits. Now, the first here, we say the basic equation governing the amount of current I in amperes in a simple RL circuit. So we want to look at RL series circuit consisting of a resistance R in ohms, an inductor L in henries, and an electromotive force E in volts is this. Okay, so that is what you have. That's the formula governing the RL circuit. L di over dt plus Ri equal to E. Now already that is looking like first order differential equation. In the real sense, we can rewrite it as di over dt, okay, is equal to R over Li, okay, plus R over Li is equal to E over L, okay. So now, but for RC series circuit, this is exactly what we have. That's the formula: dq over dt plus 1 over RCq equal to E over R. Now the Q there stands for charge, the T is time, R is the resistance of the resistor measured in ohms, C is the capacitance of the capacitor measured in farads, E is the EMF of the cell, and YR is the resistance of the resistor, like we've mentioned. Now we see a question here. It says that in an RL circuit has an EMF of 5 volts, okay, a resistance of 50 ohms, and an inductance of 1 Henry, and no initial current. Find the current in the circuit at any time t. Okay, so here we can see that the EMF, which is your E, is equal to 5, okay, and your resistance R is equal to 50 ohms, and your inductance L is equal to 1 Henry. Now this is our equation for RL series. If we substitute our values where L is 1, R is 50, E is 5, we are going to get this, okay, which is a differential, which is looking like a first order linear equation. Okay, so how do we go about this? This is looking like let me put it this way: dy over dx, okay, plus py equal to q. Okay, so it means that your y here is I and your x is t, your p is 50 and your q is 5. Remember, how do we go about solving this? We find an integrating factor, which is exponential integral of p dx, okay, and our p is 50. That's how we got this. An integral of 50 dt is what we have as 50t, so that's the value. Now, and the solution to the first order linear equation is that your rho y must be equal to integral of your rho q, dx plus c plus your constant c. So that's exactly what we have here. Your rho I equal to rho, your q here is 5, this is your q, then dt, okay, we should add plus c here. Now that's exactly what we have. So when you substitute your integrating factor, which is exponential 50ti, then 5 times this will give us 5 exponential 50t dt. Okay, and what is the integral? How do you integrate exponential 50t? Remember that integral of exponential ax is equal to 1 over a exponential ax. Okay, so since we have 5 here, that's why it is 5 over 50 exponential 50t, then plus c. Okay, so at this point in time, we can decide to divide through by exponential 50t. If we do that, we are going to get exactly this, So we are going to get I equal to 1 over 10, then plus c exponential minus 50t. Okay, so which is exactly what we have here. Now to find the constant, to know what the constant is, we say when t equal to 0, that means when at the initial time before the circuit begins or decays, your I is also equal to 0. So in that case here, if you substitute t here to be 0, what will be left is c exponential 0, which is equal to c because exponential 0 is 1. So, and your I is 0 too. So you're going to get 0, your I, which is 0, equal to 1 over 10 plus C. So here you see that C is equal to minus 1 over 10, which is exactly what we have here. So substituting the value of C now into this equation, we are going to get this. That I equal to 1 over 10 minus 1 over 10 exponential minus 50t. That which is the answer to the question. We are looking for current. Now, but as t tends to infinity, it means that our current, because whenever t tends to infinity, it means that exponential minus 50t will tend to 0. Okay, never forget that, because you should know your limit. That limit as x tends to 0, exponential minus x is always equal to 0. Sorry, as s tends to infinity, exponential minus x is equal to 0. So as t tends to infinity, it means that your I is 1 over 10 amperes. Okay, now we see a question here for RC circuit. It says a series RC circuit with R equal to 50, that's ohms, not watts, and C equal to 0.02 farads is connected with a battery of EMF E 100 volts, and at T equal to 0, the voltage across the capacitor is 0, of course. As T tends to 0, find the charge in the capacitor as T tends to 0, as T tends to infinity. Okay, so that's the equation here for an RC circuit. So we have dq over dt. 1 over RC, your R is 5 and your C is 0.02. Then Q equal to your E is 100 and this is 5. And that's exactly what we have here. So you see that the whole of this gives us 10, and 100 over 5 is 20, okay? Which is looking like a first order linear equation. So we go ahead to find the integrating factor, which is exponential integral P dt. So your P is 10. So you have exponential 10 dt. An integral of 10 is 10t, okay? That's how we got this. And remember, this is the solution to a first order linear equation, which is rho y equal to integral of rho q dx. But in this case now we can say rho q equal to integral of rho q, dt, since we're interested in dt. Now, if you are new to this particular video, you can look out the previous videos on first order linear equation, on the solution, how to go about it. Okay, so that is exactly what we have. We have this. Now, as we continue, we see that this now leads us to this. 20 can be brought as a constant. Then you have exponential 10t. We know that integral of exponential 10t should be 1 over 10 exponential 10t. Now, if that multiplies by 20, that will give us 2. So that's why we have this 2 exponential 10t plus t. So here we can divide through. Since we are looking for charge, we can divide through by exponential 10t. And if we do that, divide this by exponential 10t, you're left with just 2. Then c over exponential 10t will now give us c exponential minus 10t. Okay, so which is exactly what we have here. So as t equal to 0, q will be equal to 0. So in that case, if we substitute t to be 0 and q to be 0, you will get c to be minus 2. We can quickly check that out. You have q equal to 2 plus c exponential minus 10t. When q is 0, you have 0 equal to 2 plus c times exponential 0. So that means 0 is equal to 2 plus c, so c equal to minus 2. Okay. Now you can see now that if you now substitute the value of minus 2 for c, this is exactly what you're going to get. 2 minus 2 exponential minus 2t, which you can factorize to have 1 minus exponential minus 10t. But the question says, what is q as t tends to infinity? As t tends to infinity, your exponential minus 10t will be equal to 0. We've said that before. So that means you are going to get 2 into 1 minus 0. And the final answer is 2. So your q as t tends to infinity is 2. Thank you very much. Please do well to subscribe to our channel to get notification for our classes. Have a nice day.